All right, good day everyone. So I wanted to continue with a little bit more information, and like I said, you may remember how to do this and don't need any assistance, and if that's the case, then fine, you're good. You go on, you look at the problems I do, you hit pause, you try to solve it yourself, but if you get stuck, just come back to the video, okay? So I wanted to address some special cases that comes up when we are solving systems of equations. And for right now, like I said, we're doing 2 by 2s. So let's say that this is the equation that we're given. 4x minus 2y equals negative 10 and 6x plus 3y equals 12. Okay, now, granted, if I told you to solve this using substitution, which is the manner that we are choosing to start with today, okay? I told you to look for where there is a 1 for the coefficient, but we don't have one of those. So here we go. This is what I'm gonna do. Sometimes you just gotta pick one and go for it. Okay, now using what I already know, I'm gonna tell you this. I'm gonna use 4x minus 2y equals negative 10. Now, I'm going to see if my guess is right. Here's the thing. I will go through and solve this for y. Okay, so I'm going to solve for y. And it doesn't matter. Okay, you're just going to make sure that what you do on one side, you do on the other side, making sure that everything is mathematically sound. So I'm going to solve for y. And to solve for y, what I'm going to do is get rid of this 4x and make it become a 0. So to do so, I will subtract. Okay, and in subtracting 4x on both sides, I'm going to be left with negative 2y equals negative 4x minus 10. Okay, sometimes you got to deal with negatives. Still solving for y. So here's what I'm going to do. I need to make this number in front of y become a 1. So to do so, I know that if I need this to become a 1, I need to divide by a negative 2. So I'm going to divide everything by a negative 2. So what I'm going to be left with is y equals 2x plus 5. Now technically, I have solved for y, so now I can go back and I can plug this in to the second equation. So my second equation here, and remember, if I'm talking too fast, you can always hit pause or go back and rewind, or I am here in class to help you. Okay, so I'm going to take the second equation that I have. Negative 6x plus 3. In the place of y, I'm going to put that whole expression equals 12. So the first thing that I'm going to do is substitute in 2x plus 5. Okay, and then I'm going to solve this. To do so, I want to solve for x. So I'm going to distribute, and I'll write my steps on the side here. I'm going to distribute 3 to 2x and 3 to 5. Here we go. I'm going to be left with negative 6x plus 6x plus 15, because 3 times 5 is 15, equals 12. Okay, now what I am going to do is combine like terms. My like terms in this case is negative 6x and plus 6x. Wait a minute. Negative 6x plus 6x, that becomes a 0. Something is not right, because it is not true that 15 equals 12. Uh-oh. It is not true. 15 does not equal 12. This is not true. So in this case, we have no solutions. This would be, if you were going to graph it, a pair of parallel lines. At no point would they intersect. Okay, so that's our first look at special cases. Once again, remember you can rewind or press pause or anything like that to help you out. Okay, I want to do another special case. Okay, let's just say if this is what we're given as our special case. And once again, we want to solve this using substitution. All right, because that's going to be our method for all of today. So if I want to do this using substitution, I'm in luck. This top equation is already solved for y. I have y by itself, so what I'm going to do is replace this y with negative 3x plus 5 and then solve like we've been doing. So here we go. I'm going to use 12x plus 4 times y. But in the place of y, I'm going to substitute in what you have here, equals 20. So in this case, I didn't need to solve for y. I just needed to go ahead on and substitute it in. And that's what I'm going to do. So I am going to substitute in minus 3x plus 5 for y. Okay, and then I'm going to solve for x. I am going to distribute, and I hope you see a pattern here. If you're using substitution, you're going to have to distribute some things, folks. All right, so I'm going to be left with 12x because I didn't do anything with that, but I'm going to distribute this 4 to negative 3x and get a negative 12x, and then 4 is going to also distribute to 5, meaning multiply, and I'm going to have 20. All right, well, I'm going to combine like terms next. And my like terms in this case are the two 12x's. 12x minus 12x is 0. I am left with 20 equals 20. That is true. But what does that mean in terms of a special case? So in this case, since 20 equals 20, this would be an example of overlapping lines. Lines that coincide. It's the exact same equation. All of those definitions just to say that if I was to graph both of these, I would get the same line, one on top of the other. This is true, and what happens along that line is that you have infinitely many solutions. And y'all know I'm a terrible speller, so I had to pause while I wrote the word infinitely. So that's an example of your special cases. It will come up on the practice that you're doing, so don't be alarmed. If you come up with a true statement, 20 equals 20, you can stop right there. You have infinitely many solutions. If you come up with a statement like our first example where 15 did not equal 12, that's not true. That means that system of equations has no solutions. Okay. All right. So you have a little bit of practice ahead of you. Have a good day, folks. Thank you for watching.